Ever wondered why a block of iron sinks in water while a ship made of the same material floats? This seemingly contradictory phenomenon can be explained by understanding the properties of matter. You see, matter, anything that occupies space and has mass, possesses certain characteristics that define its behavior in different scenarios. These characteristics or properties are key to understanding and predicting how matter will interact with its surroundings, whether it's a block of iron in water or a helium-filled balloon in the air. Now, these properties can be broadly categorized into two types: extensive and intensive properties. Extensive properties depend on the amount of matter present, such as mass and volume. On the other hand, intensive properties are independent of the amount of matter, like temperature or density. To unravel this mystery, we need to delve into the fascinating world of extensive and intensive properties. Imagine having a large pizza all to yourself. As you slice it into pieces, does the total amount of pizza change? Of course not. The pizza is just divided into smaller pieces, but the total amount remains the same. This is similar to the concept of extensive properties in thermodynamics. Extensive properties are those that depend on the amount of material present. They're called extensive because they extend or increase as the quantity of matter increases. The pizza analogy we just discussed is a perfect example of this. The total amount of pizza or its mass is an extensive property. No matter how many pieces you slice it into, the total mass remains the same. But mass isn't the only extensive property. Volume is another one. Picture a jug of water. If you pour the water into a different container, its volume doesn't change. It might take a different shape, but the total volume remains the same, just like our pizza. Energy is also an extensive property. Consider a battery powering a device. The total energy in the battery or its capacity doesn't change no matter how it's used. It's still the same battery with the same total energy, even if it's powering a torch or a radio. So, just like our pizza, extensive properties change when the amount of material changes. This is the core concept of extensive properties in thermodynamics. So, keep this pizza analogy in mind. It might make your thermodynamics study sessions a little more appetizing. Now, think about a hot cup of coffee. Does its temperature change if you pour half of it into another cup? Welcome to the fascinating world of intensive properties, an equally important but slightly different character in our thermodynamics story. While an extensive property cares about the how much, an intensive property, like a true minimalist, is all about the how. Let's go back to our coffee analogy. Whether you drink your coffee from a large mug or a small cup, the temperature remains the same. It doesn't care about the quantity, but rather the quality. This is the defining characteristic of intensive properties. They do not depend on the amount of material. Now, let's dive a bit deeper. Temperature is just one example of an intensive property. There are others like pressure and density. If you take a balloon and inflate it, the pressure inside the balloon remains the same, no matter how much you inflate it. The same goes for density. A block of gold will have the same density whether it's the size of a brick or a tiny nugget. So, unlike our pizza, the temperature of our coffee remains the same, even if we reduce the amount. That's the essence of intensive properties, and this understanding is crucial in our journey through the realm of thermodynamics. So, keep brewing that curiosity, and let's dive deeper in our next scene. So, what have we learned from our pizza and coffee analogies? We've discovered that extensive properties, like the weight of the pizza or the volume of the coffee, depend on the amount of matter we're examining. These properties change as the quantity of matter changes. On the other hand, intensive properties like the warmth of the pizza or the strength of the coffee remain consistent regardless of the amount of matter. Whether you have a slice or a whole pizza, the taste remains the same. These concepts of extensive and intensive properties are vital in understanding and predicting the behavior of matter. They are the building blocks that help us unravel the mysteries of the universe, from the tiniest atom to the vast expanse of the cosmos. Remember, understanding these properties can help us make sense of why an iron ship floats while a block of iron sinks. So keep exploring and keep learning.